I've drawn a crazy looking function here in yellow, and what I want to think about is when this function takes on maximum values and minimum values. And for the sake of this video, we can assume that the graph of this function just keeps getting lower and lower and lower as x becomes more and more negative, and lower and lower and lower as x goes beyond the interval that I've depicted right over here. So what is the maximum value that this function takes on? Well, we can eyeball that. It looks like it's at this point. It looks like it's at that point right over there. So we would call this a global maximum. A global maximum. The function never takes on a value larger than this. So we could say that we have a global maximum at the point x naught, because f of x naught is greater than or equal to f of x for any other x in the domain. And that's pretty obvious when you look at it like this. Now, do we have a global minimum point the way that I've drawn it? Well, no. This function can take on arbitrarily negative values. It approaches negative infinity as x approaches negative infinity. It approaches negative infinity as x approaches positive infinity. So we have, let me write this down, we have no global minimum. Now let me ask you a question. Do we have local minima or local maxima? When I say minima, it's just the plural of minimum, and maxima is just the plural of maximum. So do we have a local minima here, or local minimum here? Well, a local minimum, you could imagine, means that that value of the function at that point is lower than the points around it. So right over here, it looks like we have a local minimum. We have a local minimum. And I'm not giving you a very rigorous definition here, but one way to think about it is we can say that we have a local minimum point at x1 is if we have a region around x1 where f of x1 is less than an f of x for any x in this region right over here. And it's pretty easy to eyeball too. This is a low point for any of the values of f around it right over there. Now, do we have any other local minima? Well, it doesn't look like we do. Now, what about local maxima? Well, this one right over here, let me do it in purple. I don't want to get people confused, actually. Let me do it in this color. This point right over here looks like a local maximum. Local, not lox, that would have to deal with salmon. Local maximum right over there. Local maximum. So we could say at the point x1, at the point x2, we have a local maximum point at x2 because f of x2 is larger